So, hello everybody, welcome to this webinar. I'm really excited to see how many people of you have registered for it and also slightly stressed by it, but that will be okay. So this webinar will be about the second generation Eurocode steel design. And also a bit its implementation into SCIA Engineer. I'm really excited to show you that part. My name is Jael Verkammer. I am a product owner at the Alplan company where I'm responsible for the product decisions for material design, so steel, aluminium, timber, composite, no concrete, for the SCIA Engineer product as well as for the Freelo products. And I also started at support a bit. Okay, I will stop my camera and launch the actual presentation. Okay, now the view should be good. So the agenda for today will be to discuss first a bit in general the second generation Eurocodes. Why is there a second generation coming? And also what is the planning? What can we expect from the timing for them in the coming years? Then we will give an overview of the biggest changes that have been made in the base steel design, so Eurocode 311. I will not go into detail because we only have 45 minutes, but I'll try to give you some idea of the biggest changes and maybe the reasoning why they have changed. And then finally, with the remaining part, we will have a little look at the implementation of this second generation in SCIA Engineer and also kind of some small improvements that we did compared to the current generation Eurocode pure SCIA Engineer usage-wise. So as usual, this webinar is on the GoToWebinar platform where all of you guys are muted while I'm presenting. That's done because we hope to upload this presentation onto YouTube. It should be there in about 1 or 2 weeks from now, normally. So you can rewatch it, or if it's very interesting, you can share it with all of your colleagues as well. But if you have some questions, please do not hesitate. You should be able to find somewhere a questions box where you can ask all of your questions. Given the high number of registrants, I have asked my colleague Bjorn from the support, who's our steel expert on the support side, as well as Peter, who's our actual big steel expert in the whole company and most specifically for the development department, to be here with us and to answer to your questions. So please make them feel useful and ask anything you would like to ask in the questions box. And yeah, I think with that we can start. So, second generation Eurocodes. Why are we making a new generation of Eurocodes? Well, not we, why are they making a second generation of Eurocodes? Well, it's been 20 years since the first generation Eurocodes came out, and since then there's been quite some evolution in the knowledge. A lot of research has been done. We've realized that some methods are maybe a little too economical and others are too conservative. So this new research has been incorporated. Also some user feedback. I think the main complaint about Eurocodes is the lack in ease of use. Now, I will put you at ease. It's not suddenly become super user-friendly, the Eurocode, but definitely you can see some points where they have made some effort into making the rules more easier to understand or giving a better overview of which methods to use. And I will show you that one later. Also, we changed our way of working in 20 years. Luckily, there's been some evolution, and mainly in the calculation capacities that we have today with our computers and with programs such as SCIA Engineer. and there has been some evolutions and industry changes. And of course, it's not like in these past 20 years there's not been any changes to the codes. There have been some amendments and annexes added, but to make some structural changes or big changes to the text, and also to unify things between the codes and between the evolutions of the amendments and annexes, it is a great idea to rewrite the actual base code and make this a bit more of an overview in the base code rather than all additions and annexes. The main structure remains the same. What's been done is that there is three new parts that have been added, one for glass design, one for fiber reinforced polymer, and one for tensioned membrane design. And then overall within the codes, there has been some changes in the evolution of the knowledge, in the assessment, and the robustness of the codes, some ease of use improvements, and there is some aim also to help the climate change topic and introduce it into the Eurocode, for example, by adding more rules about retrofitting and reuse of current structures, and adding rules of those into the codes. Now for the planning. First, let's look at the bottom graph. Here you can see the timeline for the formal votes, so the final votes of the new parts for second gen Eurocode, and you can see that this has been ongoing already for 4 years now. So the first one that was finalized is the glass design code, and masonry soon followed, and the third one is the one we are discussing today. It's the base design for hot rolled steel. And then since then, a lot of work has been done. Also at the end of 2023, you see that the price for fire, cold form design, plate design, connection design have been formally voted. And today we are right in the middle of the big rush and of most of the final versions and formal votes that will be finalized for the new text. And then by March 2026, the aim is to have the final definitive text available for all codes. This is the time where every country will be able to start drafting their national annexes, although I know that for the parts that have already been finalized, these national annexes in some countries are already being set up. And all of this work will need to be done for the 30th of September 2027, which will be the date of publication for the second generation Eurocode. So from that date, they will be official for use. And finally, in the beginning, in March of 2028, there will be the withdrawal of any conflicting standards. That means that first generation Eurocode will be removed and no longer valid for use. On the 30th of March 2028 is the current target. So that leaves us with exactly about 3 years from now to have everything ready for you guys. And since you guys are here, that means you guys are also already preparing for it, so that's good news. Okay, so let's then look into what has changed for the steel design and overview of the changes between both. I have only 45 minutes today, so that means that I will not be going into the details of the formulas and this factor has changed and this is like, I will not have the time to go into the full nitty-gritty details of everything, but surely there will be more in-depth trainings organized. I know in Belgium we will collaborate most likely with our InfoSteel partner on giving trainings on the second gen Eurocode more in depth. And in other countries, you should also find such instances. But if you don't, we also plan at SCIA Engineer to organize with our support team in-depth trainings on the second generation Eurocode in the coming months or year. So definitely let us know if you have some interest in that. But today I will just aim at giving you an overview. First, not about the part 1.1 specifically, but let's look a bit at what's changed in the parts of the Eurocode. Some parts have been removed, like the one for pipelines, and some have been changed or merged, and other parts have been added into the code. And I'd like to put emphasis on the changes to part 112, which was the part that handled the steel grades up to S700, so from S460 up to S700. The aim was to remove this part by integrating it into the existing parts, so part 1.1, 1.5, 1.8, 1.9, and 1.10. And this has been done, but after doing this, they decided to still keep the part 1.12 and to add additional rules for steel grades even up to S960. So now the part 1.12 will handle the steel grades from S700 to S960. And on the other hand, we have some additional new parts. Specifically, the top two are exciting to me. Part 1.14 will talk about the design assisted by finite element analysis. So it's not yet finalized, so I'm really looking forward to read what will be in there. And second part, 1.13, will handle web openings in steel beams. The part is quite analogous to the SC4 part about composite beams with large web openings. So it is known, but it will be exciting to have a proper way of dealing web openings described into the Eurocode and hopefully integrated into SCIA Engineer also in the future. Okay, and I said again, I lied to you, I would talk about 3.1.1, but also 1990 will affect our steel design, and it's already integrated the changes for there into SCIA Engineer, so I will quickly go over them as well. And the first change is actually a renaming of the design cases. So you have the set B and the set C that you guys probably all know, and they have been renamed into verification cases. So there is verification case 1, 2, 3, and 4 now in the second gen Eurocode. And then a new SLS case has been added. So there is combination rules for SLS seismic case, a new permanent load action of water, and also water-related variable load actions have been added, and as you can see, are also available into SCIA Engineer. All of these come, of course, with their own combination factors where there have been some changes. So you have the consequence classes with the consequence factor to take these into account. And then at the bottom graph, you can see per verification case the partial factors to be taken into account. And you can see also there the addition of a partial factor specifically for the water case. Then finally we jump into the base steel, where the first change is the addition of the materials up to S700. So as I said, formerly they were in the part 112 and now they've been integrated into part 1.1 and also, as you can see, integrated into SCIA Engineer, as well as an addition of hot rolled flat products for cold form materials. Then classification. I hope all of you by now know the Semicon Plus valorization project. It's one that I have talked about in many webinars and one that we already had in SCIA Engineer available and active by default, but as a chosen setting by the users, which is some research that continued on the Eurocode and has now been integrated into the code itself. So there are some modifications for the classification limits that are taken into account. But most importantly, there is this rule for class 3 cross sections, where in the base code you would just use the elastic resistance for class 3 sections, but from research we have shown that we can actually take account of some more resistance the closer we get to the plastic limit, and therefore the resistance is taken as some interpolation between the full plastic resistance and the elastic resistance. And so this one has been added into a code as an annex as well. And then secondly, for classification, there is now a distinction in classification for circular and elliptical sections in internal forces. So elliptical, those are new. Circular were already there, but they had the same classification regardless of whether it was in compression or in bending. And now you can see that there are different limits depending on which force components are present, and also the elliptical sections are taken into account. And thirdly, there is also now effective sections available for circular and elliptical cross sections. So that means that you can now calculate with a class 4 tubular section. Next is a change in the global analysis rules, and this is where the part of the ease of use comes forward the most. I remember from my time at support how much of the steel code training was about trying to make the rules for whether or not you needed a second order analysis or third order analysis, whether you needed memorable imperfections or global imperfection, making this clear for our clients, and it was very unclear in the code as well. Whereas now there is a really easily understandable flow chart available that you can just follow whether or not the rules apply, and then arrive into a method 0, method 1, method 2, method 3, method 4, method 5, and then there is a link to the chapter on how to deal with this method, as well as written which imperfections you should use, whether it's a sway imperfection, a member bow imperfection, or a member bow imperfection including torsional effects, and then if you are running first order or a second order analysis. I think the biggest change there, because most of these methods actually follow the same logic as they used to, the biggest change is the addition of a check for the non-sway member buckling mode. So we all know the rule with the alpha critical for this global buckling mode. If this one is over 10, then we can use first order analysis, and if it's lower than 10, then we need to do a second order analysis with the imperfections that come with it. This has remained unchanged. What's been added is a rule for local buckling mode, where if this alpha critical is bigger than K0, and in the base Eurocode, this K0 is set to 25. So if alpha critical is bigger than 25, then we consider that there will be no buckling effects at all. So we don't need any imperfections, and we run a first order analysis. And then if this is not the case, then we input a sway imperfection. We can still run a first order analysis if alpha critical for the global mode is bigger than 10. And if it's smaller than 10, then we also need to do a second order analysis. So small changes in how it practically works, but a big change in how easy it is to follow and to arrive in the proper methods and which imperfections to use. In the global imperfections themselves, there's been added some distinction between plastic and elastic verification. There is a different value that you will get for the imperfection to take into account for both cases. And for the local imperfections, there's been some small changes in the bow imperfection values based on recent research. In some cases, they are more economical, in other, they are more conservative. But in all of the cases, they should be closer to reality. So overall, it's a good news change. And then for the buckling curve, they have added rules for the material strengths up to S700. So this is another change of the 112 part being integrated. And then there's some small changes in buckling curves for the I section, and a distinction has been added in handling rolled L sections and welded L sections. And now we go on to the check part. So first check we have changes is the shear check. There have been some additional shear areas, one for doubly symmetric I and H sections, which have the load parallel to the flange as opposed to parallel to the web, which was already present. And also for now elliptical sections, there is a rule added. And there is a distinction in the shear area also for rolled and welded T sections, so we'll have a slightly different result there. Another change is that the part about resistance to transfer forces has been moved from the 1.5 part into the 1.1 part of the code. It remains the same check, it's just moved places. Next, we have the combined effects of bending and warping, where they have added a rule to take into account the effect of the bi-moment coming from warping effects into the reduction of the bending capacity when it's being combined. And you will see that this addition will come back in a lot of the other checks. For bending and shear consideration, also this addition of accounting for the bi-moment from torsion in the reduction of the bending capacity is there. And another change is the rule where if your present forces are smaller than half of the design forces, then the effect of shear can be neglected. So previously it was a eta value fixed to half, to 0.5, and now it is a value that's definable by the national annexes. So you will find it also in the SCIA National Annex setup menu, where you will be able to adapt this value now. And then in lateral torsional buckling, there's been some big changes, updates for doubly symmetric I and H sections. Here there is a new factor that's been added, factor FM, which is an overstrength factor. And it takes into account this part in those graphs here in red, that there is some potential extra capacity bigger than 1, depending on the shape of the bending moment diagram. So at the bottom here, I have a little image which shows in the blue lines the results obtained with the previous, also the first generation Eurocode. And then you will see in some gray dots the results from highly advanced analysis, and in the red diamonds, you will see the results from the second generation Eurocode. So you see that the results from second gen are very much closer to the real behavior than the Eurocode used to be. For high overstrength values, so on the left graph you see it's overstrength factor of 1.9. You see that it's more economical to follow a second gen. For low overstrength values, like the one on the right, oh, I mixed up left and right, so sorry. So on the right we have the low overstrength value, and there you see that the results are slightly worse than the first generation Eurocode, but still closer to the real behavior. So will be good news on some ends and bad news on other ends, but overall the differences are not huge. So okay, then we have combined bending and axial compression. This is the check that we get the most questions about, I believe, on the support side, because it's combining the lateral torsional buckling effects and the flexural buckling effects, and that's generally the check that's dimensioning in our steel design. And in the Eurocode, there used to be two methods available that you could choose on how to combine these. And previously, the method was allowed to be chosen by the national annex. Now, one of these methods, method one, specifically, often led to some explosions. So the factors to consider for the combinations, in some cases, they became artificially high, and it became very hard to make the check pass. And generally, what we recommended would be to switch then to method two, because generally in method two it would pass. But however, some NAs forced the use of method one, so then there was not really a solution for those cases. But now method two has become normative in the code, and method one has been moved to a technical report. So hopefully all of the national annexes will also take on method two as the default now, and these problems should be reduced. So that's good news. Next, some annexes are added, rules for monosymmetric sections, and of course also the by moment here has been taken into account into the formulas, just as the other checks we've seen before. Combined bending and axial tension is a check that didn't exist in the first generation Eurocode. So if you had bending and tension present, there was no mention of a check on how these forces would interact and how this would reduce the capacity. SCIA did use a check for this in before second gen, but we stole it from the American design rules. Second gen now offers an actual rule and check for this case, so now we will follow the second generation Eurocode rules on that one. And then last, also there has been some changes in the shear buckling interaction check. And that's all the changes so far and implemented into SCIA Engineer as a quick and high-level overview. Let's see the time. Perfect, 30 minutes. That means 15 minutes to show you a SCIA Engineer. I hope you guys have questions, and don't hesitate to ask them in the box for Peter and Bjorn. Give them some work. And yeah, let's maybe just open a new project. There we go. It's already in second gen. I wanted to show you how to change it. So here you can add the codes in case you are still in normal Eurocode. And there, if second gen is not added yet, you would be able to add second gen into your project. Here it was already there. Now you can see I'm working in version 25. So the second gen Eurocode for steel is already implemented in version 25. Currently today, for version 26, we are working on the cold formed part of the steel design and the upgrade to second gen. So the first part, 1.1, is already implemented. In case you would like to test it or play with it, you could always contact our support if you're interested in trying out a beta version of this one. Maybe not all of you, because that would be overwhelming. But yeah, don't hesitate if you have some interest in trying it out. We would gladly have you work in a beta version as well. So I'm not going to take first gen, I'm going to use second gen. As you can see, only for now steel has been implemented. Okay. And maybe let's have a look at the 90 part. So we have a self-weight load case, and here I'll add another permanent one. Let's remove this, and you see that we can here make it into a permanent water case. And also for the variable cases, you have now the options of these new actions, icing, water actions, wave and currents that you can add. Okay, and then in the combinations, You see that the automatic combinations have created the VC1, so verification case 1. I believe that one is set B, and the verification 3 is the set C. If we create a new case, also you see that I can create the VC3 case and also a SLS case for seismic design. New here. Okay, back to my other project. Yeah, so this one is currently in the base Eurocode. So I just wanted to show you what happens to switch it into the second gen. So I'll just switch it over to second gen. You can see that the code has been changed, and he will update our automatic load combination according to the currently selected code. So perfect. And that's it. So now I'm in second gen Eurocode design. So if you have one project to switch over, it's really not a big deal to change between both. And here I wanted to show you the national annex settings. As you can see, the look of them has changed a little bit. They now look much like our setup for concrete design, and also a lot of others like Timber design also looks like this now, and composites. So yeah, we have unified the look and feel of our setup. And here you find back, for example, the factor to take into account the consequence class and the combination factors for the added water type actions. And in the 1.1 part, here, for example, no, that's not the one I wanted to show. Yeah, here. For bending and shear, as I told you, this factor used to be fixed to 0.5, and now it's allowed to be set by the national annex. So here we'll be able to change the 0.5 factor, for example. And then, of course, some changes in the steel settings. As you can see, also this one has been updated to the new menu with the additional benefits that we can look for specific functions we need and not have to scroll through the entire menu. And you can also create your own views if you want to quickly find certain parameters. So that's quite nice improvements. And there has been a little sneaky addition to the steel check in second gen. This has nothing to do with second generation at all. It's just a functionality improvement of SCIA Engineer. Some of you who do concrete design might recognize it. It's actually a feature that allows you to ignore certain force components for the design. So by default, all of the force components are taken into account. But if I change this one to user with limit, you can actually untick certain force components. For example, if I don't want to take into account any torsion, I can just turn it off. What this means is not that there will not be torsion in the member. So torsion will still be taken up by the member. It will be accounted for in the finite element analysis. The only thing that it does is that in the check, the torsion will be set to 0, even if it is not 0. So this is quite a dangerous option, but yeah, it allows to take into account some effects that you are not able to properly model in the finite element analysis. For example, torsion is being taken up by something that is not modeled in your model. This could be a way to make it work. But I would not recommend this. I'd recommend to make just a proper model where every forces is exactly what's happening in the structure. However, what can be handy is, for example, to ignore really low values, values that can be neglected. And that's the option here. So instead of having no limit, you can put a limit in absolute values and say, okay, normal forces that are lower than 0.01 kilonewtons, so neglectable in the case of this project, I don't want to take that into account. And this will make it so that this normal force will be set to 0, and it will not trigger, for example, the combined axial and bending check. And this could help your project into, could help you into passing the check when the interaction is giving some strange factors leading to weird results as well, just by the presence of some really, really small normal force. So this is something that you could do. Let me turn off the torsional moment, so maybe we can see the effect on the check later. So that's a small addition. And then we have the changes in the ultimate limit state. As you can see, semicon plus is now disappeared from here. It will be taken into account automatically in terms of the changes into limits of the cases. But also you have this new setting, Annex B. This is where the rules on the interpolation for class 3 sections have been moved. So you can still choose to yes or no take into account this interpolation. It's just called Annex B now because that's where the rules are sitting currently. And for lateral torsion, for example, here you can switch between the general case and the new rules that I've shown you with the overstrength factor for symmetric I and H sections. Of course, this is at a project level, and maybe not all of your beams are I sections in your project. So this is a setting that you can also set with the steel member data. So I'll put it on this member here. And here you will find that per element you can also change if yes or no this is a general case or a doubly symmetric I and H section. Okay, and then final thing to show before we go into the check are the cross sections. So I've added here a CHS section. Where now classification is available. It was already available, but it didn't change depending on which internal forces you put. Whereas now, if I put normal force, you can see this section is classified as class 4. And if I change this one into a bending moment, you can see it is class 3. So you can see different class limits depending on the internal forces. And also new is an effective section. You cannot here change the type because what this would change would be in the I section, which parts of the cross section are being removed and the calculation. And for CHS sections, that just doesn't work this way. It's just a round tube, so where would we remove part of the sections? That's quite hard. So actually the effective section here is just being calculated based on the value d over t, so the diameter of our tube divided by the thickness of the walls of the tube. And this one will govern the calculation of the effective section, and then whether you are in class 3 or class 4 will define whether you use this effective section or not. So as you can see here, the A is 2.655 and the non-effective section, so the gross section, is actually 2.799. So you can see that there's a small reduction in area to take into account in the checks in case you would have a compression force on this element. And yeah, you've seen that there's quite a lot of changes to the code, but actually if you're a SCIA Engineer user, you will not need to worry about it that much. If you run now the check for 2nd gen, of course, all of these changes will be in there. And if you are curious to see why these values are different from 1st gen or 2nd gen, we will still have the detailed output with the tables and the formulas. So if you run the check and we open our report preview, we will get the full details on the check. I think the torsion here is not working because I inputted some member data where I don't ignore the first component. So yeah, I will not be able to show it to you, but in case I would ignore this component, it would be set to 0, of course, in the check. And yeah, as usual, you find all the details on the design. Here we see that it's the 2nd gen steel check and we're following the rules of the formally voted document for 311, and we have verification case 1 instead of the ULS set B combination. We have our classification, and as usual, this is the check from SCIA Engineer, just with the small changes added. I think here, this one we can show it, for example, by the presence of this overstrength factor here, which is 1.91, and the methods chosen for the symmetric I and H sections. And you can also find it back in our formulas right here in the calculation of CLT. You find the overstrength factor being taken into account. Yeah. And I believe that's it. I'm left with 3 minutes of my 45, so that's quite great timing here.